Good morning, students. Hope you have watched my earlier 3 videos. One on introduction to software. The second one is on evolution of operating system. And the third one is on time sharing multi-programming operating system. In this lecture, I'm going to discuss about one important type of operating system called real-time operating system. Why it is called real-time operating system is because of its wide applications in many real-time applications. In our previous lecture, we discussed about multi-programmed system, time-sharing system with their merits and demerits. A multi-programming system, as the name indicates, instead of having only one program in the memory, some set of programs are brought to the primary memory from the secondary memory. All the jobs which need to be executed are initially stored in the secondary memory, where it is called as a job pool. Then, depending on your main memory capacity, some set of jobs from the secondary memory is brought to the primary memory. Then, your processor start executing the program one by one in the primary memory. In case of multi-programming system, what happens is the processor start executing the first program or first job. After executing, it go to the next one, then the next one, and the next one. One important characteristics of a multi-programming system is that the processor start executing the second program in two situations. One is either after completely executing the previous job, or after, if a particular job has any input-output operation. In that case, for doing input-output operation, processor is not required. What is required is input-output device. In that case, processor automatically moves to the next program or next job in the main memory. So these are the two situations where the CPU switchover takes place from one job to another job. One is if there are no IO operation, it will complete the previous job, then go to the next one. In the second case, if the previous job has any IO operation, then it goes to the next job. So the next program will get the CPU only after if any one of these two situations occurs. But in many applications, what happens is, in that case, the waiting time will not be uniform. For the first job, no waiting time. For the second last job, the waiting time is too much, etc. So this is not a desirable situation. In some application, we want a waiting time to be as uniform as possible. In that case, we'll go what is known as time sharing operating system. In a time sharing operating system, just similar to multi-programming operating system, some set of jobs are brought to the primary memory. Then the operating system fix up some time limit called time quantum. Then as usual, the processor start executing the first program. If the program has no IO operation also, in that case, what it will do is, it will check what is the requirement for that job. If the total CPU time requirement is more than the time quantum, then the processor execute that job only for one time quantum duration. Then immediately it switch over to the next job. Execute that job also for only maximum of one time quantum, then move to the third job. In that case, it will move from one job to another job. After reaching the last job, comes back to the first job, again execute the second job also, or execute the first job again for next one time quantum. So in that case, in a time sharing operating system, every job in the main memory will get the CPU maximum for one time quantum in one iteration. So here, when compared to multi-programming operating system, no job has to wait till the completion of the previous job. So it leads to a better or uniform waiting time. And in the previous class, we also discussed about what are the advantages of multi-program system, what are the advantages of time sharing system, what are the drawbacks of multi-program system, what are the drawbacks of time sharing system. The main objective of this session is to introduce a new type of operating system called real-time operating system. Here we'll discuss about the different categories, how a real-time operating system works, what are the different categories of real-time operating system, what is the major difference between the different types of RTOS, and where actually RTOS is useful, for which application we can use real-time operating system. At the end of this session, you should be able to understand how a real-time operating system works, what are the different categories or different types of real-time operating system, where each category is useful, where actually real-time operating system is useful. In the real-time, we have several categories. we have two different categories. In that case, which category is useful for which application? These things we are going to study in after attending the session. You should be able to understand these concepts, or you should be able to tell the answer for these questions. A real time is a special type of operating system similar to your time sharing operating system and multi-programming operating system. In a real time operating system, why it is called real time operating system is, in a real time operating system, we have some rigid time constraint, a rigid time limit. Here, the processing has to be completed within the time limit. If any processing, even if it is completed after the time limit, it has no use at all. It will lose its significance. In a real-time operating system, for your computer system, one sensor is connected. The sensor purpose is to bring the data to the computer. After receiving the data given by the sensor, the computer analyze the data, adjust some controls, and modify the sensor input and do the processing. After processing, it gives out the corresponding output. But the problem or the main characteristics of a real-time operating system is, whatever may be your computation, it has to be computed, it has to be over within the time limit. Even slight delay is not acceptable. Even if your system gives you correct output, even if your system completes its functioning after the time limit, it has no use at all. So in a real-time operating system, all your processing must be completed within the fixed time limit or fixed time constraint. Otherwise, we say that the system fails. Real-time system were actually useful. We can see number of applications of real-time operating system. Some of the major area where real-time operating systems are used are, one is medical imaging system to detect cancers and other things, industrial control system, satellite launch, weather forecast, missile application, etc. Depending on their characteristics, real-time operating system have been categorized into two types: hard real-time operating system and soft real-time operating system. One is called as a HRTOS and second one is SRTOS. What do you mean by a hard real operating system? A hard real operating systems are deterministic. Mean, in a hard real-time operating system, we know what is the input. We also know what is the output. The characteristics here, the input should be given by the sensor to the computer. The computer receives the sensor input, modifies certain controls, etc., process the input and gives out the output. But at the time of giving the input only, we know what output we should get it. The thing is, the output we should get it within the time limit. Here, the response time, the time of submission of your program and the time of output. Suppose if you submit your job at 2 o'clock and you get the correct output at 2:10, in that case, the 10 is called as the response time. But generally, in a real-time operating system, real-time operating systems are used for many real-life applications where the response time is always in milliseconds. That means if you submit a job at 3 o'clock, your output will you should get the output just after 3 milliseconds, 5 milliseconds, 10 milliseconds, etc. So the response time is measured not in second; it is generally measured in milliseconds because the operating system is very, very powerful and very, very fast. And your expected output should come at exact time. In any real-time operating system, getting output is not the major condition. Getting the correct output at the exact time is very, very important. In the hard real-time operating system, the deadline is kept and all your computation should be finished within the deadline. Otherwise, the system performance is completely waste. We say that the system miserably fails. Some of the areas where hard real-time operating system is useful is, one is satellite application, other one is missile system. In a satellite application, what happens is your launching station has fixed everything and they will estimate what is the escape velocity. They have all the calculation. What is the escape velocity of that? When the satellite has to start launching and at what time it has to reach the Earth it has to escape from the Earth's orbit. All these things are already calculated. So we know what is the input, we know what is the output, at what time the satellite has to reach the destination. All things are already determined. But your thing is, even 1 second, if the satellite is not reached in the at the corresponding time, it will come down, it will fall. So many of the satellite have failed because of these things. Because even 1 millisecond delay is also, it leads to disastrous result. Missile system, we know the distance from, in a missile system, we know what is our source place, what is the enemy's place, how much distance is there from the our end to the enemy's end, at what time the missile has to hit. All these have been already calculated and everything is fixed. One thing is, the missile has to hit the enemy's aircraft, etc., at an exact time. 1 millisecond delay also, it is useless. That's why it's called as deadline is very, very hard deadline. That's why it's called as a hard real operating system. In a satellite launching, especially 1 nanosecond delay also, sometimes it will lead to disastrous result. The other type of operating system is soft real-time operating system. The major difference between a soft real-time operating system and a hard real-time operating system, in the case of hard real-time operating system, your processing must be completed exactly within the time limit. Suppose there is a computation, you have a problem, and assume that the problem takes 10 milliseconds, and in that case, what happens is, you should get the correct output exactly at the 10 second. Even if you get the result at 9 second, also no use. Even if you get the result at the 11th second, also no use. Whatever time you are fixing, your output should come exactly at the same time. But in the case of soft real-time operating system, even though deadline is there, but the deadline is not very, very rigid. Slight delay is also acceptable in case of soft real-time operating system. So in a soft real-time system, the meeting of deadline is not compulsory for every task. You have some set of 10 tasks, 11, 15 tasks, etc. Out of some task, 1 or 2 tasks, even if you don't reach the deadline also, even if you don't satisfy the deadline also, nothing serious will happen. But this is opposite in case of hard real-time operating system, because every task deadline is there. Even the soft real-time system also cannot miss the deadline for every task. For 1 or 2 tasks, it's okay. And in the case of soft real-time operating system, what happens is, you have a process which is very, very important. It is considered as a critical process. Then your system keep on executing the critical process. All of a sudden, a new process arises. It is not so important, then your computer system will not give the importance for that one. So always for every job, some priority is fixed. Always high priority jobs are processed first. Even in a soft real-time operating system also, if the deadline is missed for every time, the performance of the system will be worse and cannot be used by the user. Here, the response time is little bit more when compared to hard real-time operating system, because in a hard real-time operating system, the response time is measured in milliseconds. But it is here, the response time is quite more. Means the time of submission to the time of completion, the duration is little bit more in case of soft real-time operating system compared to hard real-time operating system. Some of the examples of soft real-time operating system are computer games. Many of the computer games like PUBG and all. There, what happens is, even 1 or 2 second delay also, nothing serious will happen. Because if your work is so critical, then definitely will not go for soft real-time operating system, we will go for hardware. Example, computer games, online game, computer system also. Assume that I have written a program to find the matrix of addition of 2 matrices. Then we know what is the input, we know what is the output also. But we don't fix up the time limit for the task, because even after 2-3 second delay also, nothing serious will happen in case of soft real-time operating. Only thing is, what input we know, what output we should get, that also we know. What our aim is to get the corresponding output. Time is not so given so importance in case of soft real-time operating system when compared to hard real-time operating system. What are the advantages of real-time operating system? It is suitable for real-time applications like satellite launch, missile, etc. And the result in case of real-time operating system, both hard real-time operating system as well as soft real-time operating system is very, very accurate. The drawback is very expensive, because in both hard real-time operating system and soft real-time operating system, you should have a corresponding sensor which brings the data to the computer. And it is not suitable for all such applications, because many of the applications, the budget is very, very important. In such case, don't deploy real-time operating system. So the usage of real-time operating system depends on the application. For every application, if you try to implement, then what happens is it becomes very, very expensive. Then let us see some of the major difference between hard RTOS and soft RTOS. In the case of hard RTOS, the size of the data file is small, because the computation has to be finished within exactly time. It has to be completed within that limit. 1 millisecond delay also is useless. Therefore, that's the reason in the case of hard real-time operating system, the sensor which brings the data in the form of file, the file size is generally small, but it is large in case of soft RTOS. The response time is very, very small in hard RTOS and little bit more in case of soft RTOS. Highly restrictive. That means the deadline is very, very restricted. Not so highly restrictive in the case of, because slight delay is also acceptable. Safety is very, very critical. That's the reason for satellite application, not only launching is very important, safety of your data is also very, very important. But safety is not given utmost importance in case of soft RTOS. When you're playing a computer game, safety is not so important for us. There our intention is to reach the destination or reach the target. In case of an error, in a hard real-time operating system, the whole computation has to be rolled back. So you have to start from the beginning. You might have seen in the newspaper, satellite, many of the satellite fails. In that case, they can't start from the point where the failure has occurred. They have to start all the process from the beginning. So that's the reason in case of hard RTOS, if any error occurs, the computation has to be completely rolled back. In a soft RTOS, what happens here? At after doing some processing, a point is created called checkpoint. Then the next processing starts. After processing some more data or processing some more time, then again the second checkpoint is kept. So there what happens is, if any error is occurred, at least the system goes back to its previous state. Suppose we are processing some 20 database record. After processing first 20 record, I will keep the first checkpoint. Then after we start processing 21st record to 40th record. After finishing 40th record, I keep the second checkpoint. Then we started processing 41st record. At the time of processing the 41st record, something happened. In that case, all the 40 records will not be deleted, or you need not go back to the first record. At least where the previous checkpoint at the end of 40th record. In that case, only the 40th record, previous record will go back. After your first checkpoint is at 20th record, and some error has occurred in the 26th record. In that case, at least 6 record has to be deleted, because the previous checkpoint is at the end of 20th record. Some of the areas where hard RTOS used is satellite system, and the soft RTOS example is computer games. Okay, students, today I'm going to conclude today's session at this point, and these are some of the examination questions. That's for your review. What is real-time operating system? Mention its characteristics. Give some examples of real-time operating system. Any example you can think, you can give it. It need not be only satellite, missile launch, etc. What are hard real-time and soft real-time system? Here you have to give the characteristic. In the case of hard real-time operating system, time constraint is a major point. In the case of soft real-time, every time constraint you cannot maintain. For some tasks, even if you don't reach the deadline within the time limit also, nothing serious will happen in case of soft RTOS. Time sharing is better than multi-programming justify. Actually, this question, even sometimes a real-time operating system also can be of time sharing type. Give some major differences between hard RTOS and soft RTOS. I have given a complete table only. I have framed some 5 multiple choice questions to check your level of understanding of today's session. Computation is dash in soft RTOS. Aborted, completed, rolled back to previous checkpoint, repeated. Especially in the case of hard RTOS, it is completely aborted. You have to go back to the initial point. But here in the case of soft RTOS, it is rolled back to previous checkpoint. The correct answer is C. Satellite application is a dash. Hard real-time system, soft real-time system, not a real-time system, none of these. Definitely the example for hard real-time system A. Which of the following is not a characteristics of real-time system? Rigid time constraint, any hardware, it's not real time. Rigid time constraint is definitely there, both in hard and soft. Sensor give data to the computer. In any of the RTO real-time operating system, the data should be given to the computer through the corresponding sensor. Getting correct output? No. Getting correct output is not a characteristic of real-time operating system. The correct characteristics of a real-time operating system is to get the correct output at the correct time. Time is the major important characteristic. And expensive. True. Expensive is also true. The correct answer is C. Restrictive type of real-time operating system is soft. What do you mean by restrictive? You have some limitation on the time limit. The time limit takes the important factor in the case of real-time operating system. That too in case of hard. So soft, hard, both A and B, neither A and B. The correct answer is hard. Response time is more. Generally, response time actually in any of the real-time operating system, if the response time is very less, then we say that one it's a good real-time operating system. But response time generally less in case of hard RTOS when compared to soft RTOS. So the correct answer is A. Or response time is more in dash. The correct answer is soft. Okay, correct. B. So students, in today's session, we studied what do you mean by a real-time operating system? What are the major characteristics of a real-time operating system? How real-time operating systems are categorized as hard RTOS, soft RTOS. Why it is called hard RTOS and why it is called soft? Because we have some soft corner. For every task, even if you don't reach the deadline also, no problem. And what are the major differences between hard RTOS and soft RTOS? If you have any doubt in today's class, or even if the previous 3 sessions also, you can send your question to my WhatsApp number 9880192329. You can send your queries to my mail, or the best thing is post all your doubts, comment everything in the Google Class. Even if you write this class also, you can post your comments in the Google Class. Even if you need any modification, any changes in the way of delivering of lecture, then also you can indicate your observation in the comment section in the Google Class. Hope you have enjoyed today's session. Good luck. Thank you.